Two 7-year-olds. Same genes, same house, same parents. One reads better than the other. 9 years later, the stronger reader scores higher on every intelligence test, not just vocabulary, logic puzzles, pattern recognition, abstract reasoning. The gap widened because one child learned to decode letters faster. You think intelligence is fixed at birth? Twin studies from England to Norway to Colorado say otherwise. Between 1994 and 1996, 15,000 families in England and Wales received letters. Researchers at King's College London needed twins, not for medicine, for measurement. They wanted to know if reading makes you smarter or if smart kids just read more. The question matters. If reading builds intelligence, we can intervene. If intelligence drives reading, we cannot. The study became the twins' early development study. 16,000 pairs enrolled. 13,000 remained active through 2023. Every child tested at age 2, 3, 4, 7, 8, 9, 10, 12, 14, 16. Phone assessments, web-based cognitive tests, booklets sent home, teachers submitted reports. Schools provided national pupil database records, DNA samples from more than 10,000 individuals, over 400 published papers, 140 researchers across 50 institutions worldwide. One twin finds a friend who loves books. One twin discovers graphic novels at age 6. Those differences stack. In 2014, Stuart Ritchie and his team at the University of Edinburgh published results in the journal Child Development. They analyzed 1,890 identical twin pairs from the TED-S cohort. Reading ability and intelligence measured at ages 7, 9, 10, 12, 16. The twins who read better at age 7 scored higher on IQ tests at age 9, controlling for their intelligence at age 7. The effect repeated at age 10, age 12, age 16. The reading advantage at age 7 predicted intelligence gains across 9 years. The twin with weaker reading fell further behind, not just in vocabulary tests, in nonverbal reasoning, in matrix problems that use shapes, not words. If you value documented cognitive development and educational neuroscience like this, subscribe. It's the best way to support our work. Also comment from which city you're hearing this from. Also, this script is researched and factual, using sources from the Child Development Journal published July 24, 2014 by Ritchie, Bates, and Plomin, and the Twins Early Development Study Database at King's College London, founded in 1994 and directed by Robert Plomin for 25 years, now led by Thalia Ely. These are longitudinal twin study datasets tracking 15,000 families with repeated cognitive assessments and DNA analysis, not pop science summaries. Now back to the information. A child with average intelligence but strong reading skills gained more IQ points by age 16 than a child with high intelligence but weak reading skills. The mechanism cuts both ways. Good readers improve. Poor readers fall behind. Ritchie called it environmental amplification. Small advantages compound. One extra year of reading fluency might add vocabulary. Vocabulary makes the next book easier. Easier books mean more reading. More reading builds general knowledge. Knowledge feeds abstract thinking. Abstract thinking lifts nonverbal IQ. The Matthew effect in literacy. Those who have get more. Those who lack lose ground. The twin design ruled out genetics. It ruled out family socioeconomic status. It ruled out parenting quality. The only variable left was reading skill itself and whatever unique experiences shaped it. A library card. A diagnosis caught early. A summer reading program. A friend who shared books. Reading volume did not add extra gains beyond skill. This suggests mechanics drive the effect. Decoding fluency, comprehension speed, orthographic mapping, not time spent holding books. The brain work matters more than the book count. Ritchie pointed to orthography studies by Rosenthal and Airy in 2008 and Ricketts, Bishop, and Nation in 2009. Children who learned new words with their spellings shown remembered meanings better than children who only heard the words spoken. The visual scaffold of letters anchored vocabulary in memory. Skilled readers access this scaffold automatically. Every unfamiliar word becomes a vocabulary lesson. Poor readers avoid reading. They miss thousands of incidental word exposures. By age 16, the vocabulary gap between twins born with identical genes reached 15 to 20 IQ points in verbal subtests. Ritchie speculated that reading builds abstract thinking through narrative immersion. Fiction requires tracking character perspectives. Historical texts demand imagining other times. Science writing forces visualizing processes you cannot see. These mental simulations train cognitive flexibility. The brain learns to hold multiple representations. This flexibility transfers to matrix reasoning and spatial tasks. Another explanation involves general knowledge accumulation. Stronger readers encounter more facts across domains. More facts mean denser semantic networks. Denser networks support faster inference. Faster inference improves performance on timed reasoning tests, even when the content is nonverbal. The data cannot isolate one mechanism. Likely both operate A separate study from University College London in 2013 examined 33 teenagers scanned twice with MRI, approximately 4 years apart. Kathy Price and her team measured verbal IQ and reading ability at both time points. They found that reading ability at time 1 predicted changes in verbal IQ better than verbal IQ at time 1 predicted its own change. Good readers gained IQ points. Poor readers lost ground. 75% of the variance in IQ change linked to behavior was also linked to gray matter change in the left premotor and somatosensory cortex. This region activates during reading, but not during object naming. Skilled readers showed higher blood flow there. The researchers proposed that good readers engage more speech monitoring during silent reading to catch errors when processing is fast. This monitoring strengthens connections between language areas and motor areas. The strengthening shows up as structural change. The structural change correlates with IQ gains. The brain physically reshapes in response to reading practice, not just in childhood, in adolescence too. The reform rolled out in stages across different municipalities. Some regions implemented it in 1960, others in 1975. Every Norwegian male takes an IQ test during compulsory military service. In 2012, researchers Christian Brinch and Taryn Galloway compared IQ scores of men who experienced the extra schooling to those who did not. Same birth cohorts, different municipalities. The extra schooling added 3.7 IQ points per year. Schooling increases intelligence. Reading is a large component of schooling. The effect likely flows partly through literacy gains. More years in school means more reading instruction, more text exposure, more vocabulary drill, more comprehension practice. The brain responds, synaptic connections strengthen, white matter pathways myelinate. The ventral reading stream becomes more efficient. Intelligence scores climb. Skilled readers activate this region within 200 milliseconds of seeing a word. Poor readers rely on right hemisphere compensation, scattered activation, inefficient processing. Intervention studies show that explicit phonics instruction in struggling readers builds left hemisphere pathways over 6 months. Brain scans before and after training reveal increased activation in temporal and parietal reading regions. Structural MRI shows white matter changes. The brain is plastic. It rewires with practice. Colleagues at the Wellcome Trust Center for Neuroimaging and the longitudinal Norwegian schooling study published in 2012 by Brinch and Galloway examining IQ test data from military conscription records. These are peer-reviewed studies with brain imaging evidence and natural experiment designs, not anecdotal claims. Now back to the information. Ben Shachar and colleagues tracked 53 children from ages 7 to 12 with annual MRI scans in a longitudinal study published in Cerebral Cortex. They focused on the ventral occipito-temporal cortex, also called the visual word form area. Brain volume in this region decreased with age, but children with greater volume decreases, showed better reading fluency, word recognition, and rapid naming. Counterintuitive but typical of brain maturation. Cortical thinning reflects synaptic pruning. Pruning eliminates weak connections. Strong connections remain. Efficient networks result. The children with faster pruning in reading regions became better readers. The better readers gained IQ points. The process loops. Reading skill drives brain change. Brain change supports more reading. More reading boosts intelligence. Intelligence enables harder texts. Harder texts build more knowledge. Knowledge feeds intelligence again. Diffusion tensor imaging studies measure fractional anisotropy in these tracks. Higher anisotropy means better structural integrity. Children at risk for dyslexia show reduced anisotropy in the left arcuate fasciculus before they learn to read. The structural difference precedes literacy instruction. It predicts later reading difficulty. Intervention can still help. Intensive phonics builds compensatory pathways. Not all children respond equally. Genetics matter, environment matters, but plasticity remains. The brain can learn new routes. This anchoring stabilizes memory. Skilled readers benefit from this scaffold thousands of times. Every unfamiliar word in a book becomes sticky. The spelling provides a retrieval cue. Poor readers encounter the same words but decode them slowly. Slow decoding taxes working memory. Working memory overload prevents encoding the meaning. The word disappears. No vocabulary gain. The skilled reader pulls ahead by hundreds of words per year. By age 16, the cumulative advantage reaches thousands of words. Vocabulary correlates 0.6 to 0.7 with verbal IQ. The connection is direct. Spatial manipulation. None require reading. Yet stronger readers improved more. Ritchie proposed narrative transportation. Fiction pulls readers into simulated worlds. The reader tracks character beliefs that differ from reality. This is theory of mind practice. Theory of mind correlates with executive function. Executive function correlates with fluid intelligence. The chain connects reading to abstract reasoning through mental simulation. Another path runs through knowledge. Nonverbal reasoning tests often draw on implicit knowledge. A pattern might follow physical laws. A spatial problem might reflect real-world constraints. Broader knowledge helps even on abstract tests. Readers accumulate more knowledge. Knowledge leaks into reasoning performance. Brian Byrne in Australia, Richard Olson in Colorado, Stefan Samuelson in Norway, they tested identical and fraternal twins in preschool for pre-reading skills, phonological awareness, letter knowledge, print concepts. Then they followed the twins through kindergarten, first grade, second grade. They measured reading, spelling, and cognitive skills annually. The goal was to separate genetic influence from shared family environment from unique individual environment. Fraternal twins share 50% of genes. Identical twins share 100%. Comparing within pair similarity reveals heritability. The preschool data from 146 pairs in Australia, 284 in the United States, 70 in Norway, showed moderate heritability for pre-reading skills. Phonological awareness was about 50% heritable. Letter knowledge, less so. Shared environment mattered more for letter knowledge. Parents who teach letters raise both twins' scores. Genes matter less. But reading disability showed higher heritability, around 65%. Some children face biological obstacles. Intervention helps, but genes constrain the ceiling. The Colorado Learning Disabilities Research Center began in 1982. It tested over 1,400 twin pairs by 2013. They found that reading disability clusters in families. If one twin has dyslexia, the identical twin has 70 to 80% chance of dyslexia. Fraternal twin has 40% chance. Siblings have 30 to 40% chance. Linkage studies identified chromosomes 6 and 15 as hotspots. Specific genes like DCDC2, KIAA0319, and DYX1C1 show associations with phonological processing deficits. These genes affect neuronal migration during fetal development. Cortical structures form improperly. Reading circuits wire atypically, but these genes explain only small percentages of variance. Many genes contribute tiny effects. Environment modulates everything. A child with genetic risk who receives early intensive phonics may read at grade level. A child with no genetic risk who receives poor instruction may struggle. The interplay matters more than either factor alone. They found that reading ability at 14 predicted verbal IQ change. Better than IQ at 14 predicted its own change. The effect was strongest when reading and IQ were discrepant. A teen with strong reading but average IQ gained the most points. A teen with average reading but high IQ gained little. The brain imaging revealed 75% of the variance in IQ change associated with behavior was also associated with gray matter. Change in the left premotor cortex. This region is part of the motor speech network. It activates during silent reading in skilled readers. The researchers suggested that good readers engage in covert speech monitoring. They subvocalize while reading. The motor cortex tracks potential articulation. This monitoring catches errors. It also strengthens phonological representations. Stronger representations support vocabulary learning. Vocabulary gains drive IQ gains. The loop closes. Stanislas Dehaene calls it the neuronal recycling hypothesis. Old circuits learn new tricks. The plasticity required for this recycling is greatest in childhood. The sensitive period for language extends through adolescence. Reading development tracks this period. Children who learn to read early wire the circuits during peak plasticity. The connections stabilize strongly. Children who struggle wire the circuits less efficiently. Compensation is possible but costly. Right hemisphere regions activate more. Processing is slower. Automaticity never fully develops. The struggling reader remains effortful. Effortful reading discourages reading. The Matthew effect compounds disadvantage. Language pathways. Second, cognitive pathways third. Reading builds on language pathways. Language builds on sensory pathways. Early language exposure matters. Parent-child conversational turns at age 2 correlate with brain structure at age 5. Romeo and colleagues in 2018 measured conversational turns using wearable recorders. They found that turn count predicted left hemisphere white matter organization. Specifically, the arcuate fasciculus and superior longitudinal fasciculus showed higher fractional anisotropy in children from high turn families. These are the same tracks that support reading. Early language input wires the brain for later literacy. Literacy then drives intelligence. The chain starts in infancy. She measured receptive vocabulary, reading comprehension, and motivation to read in 2nd through 4th grade. Early book reading predicted vocabulary and comprehension. It did not predict decoding. Decoding requires phonics instruction. Comprehension requires vocabulary. Vocabulary comes from exposure. Books provide exposure to rare words. Conversations do not. The average children's book contains more sophisticated vocabulary than the average dinner table conversation. A 2-year-old hearing books daily encounters thousands of low-frequency words. These words reappear in school texts. The child recognizes them. Recognition speeds comprehension. Comprehension enables learning from text. Learning from text builds knowledge. Knowledge correlates with IQ. Struggling readers who receive intensive phonics show brain changes after 6 months. Temple and colleagues scanned children with dyslexia before and after 80 hours of explicit phonics training. Post-training scans showed increased activation in left temporal and parietal cortex during reading tasks. The activation patterns shifted toward those seen in typical readers. Reading scores improved, comprehension improved, vocabulary improved. IQ scores were not reported in that study, but other studies show that reading intervention boosts verbal IQ. The effect is not large, 5 to 7 points over 2 years. But 5 points is meaningful. It shifts a child from below average to average, average to above average. The boost is real. The mechanism is reading skill. And literacy. Researchers measured parent talk and conversational turns when children were 18 to 24 months old. They used the Lena recorder, a device that sits in the child's clothing and captures all audio for 16 hours. The software counts adult words, child vocalizations, and conversational turns. At age 5, the children underwent MRI scans. Higher conversational turn counts at 18 months predicted higher fractional anisotropy in the left arcuate fasciculus at age 5. This tract connects posterior language areas to frontal speech areas. It is critical for phonological processing. Phonological processing predicts reading success. Reading success predicts IQ gains. The chain starts with parents talking to toddlers. The effect size of conversational turns on brain structure was moderate. About 0.3 correlation, not huge, but persistent. Importantly, the effect was specific to conversational turns, not passive adult word count. Children benefit from back and forth interaction. Monologues do not build the same circuits. The child must respond. The response engages motor speech areas. Motor engagement strengthens the pathway. The pathway supports reading. The logic is consistent. Early interaction builds language networks. Language networks support literacy. Literacy builds intelligence. The TEDS study tracked these non-shared effects. It found that reading was a major source of within-family IQ divergence. 2 children, same genes, same home, different reading skills. The stronger reader gained 6 to 10 IQ points over 9 years relative to the weaker reader. 6 to 10 points is 2/3 of a standard deviation. It is the difference between average and above average, between above average and gifted. The difference came from reading. The IQ gain cannot come from genes because the genes are identical. It cannot come from shared environment because they grew up in the same house. It must come from unique experiences. The reading difference is the candidate experience. Ritchie tested alternative models. He included reading exposure, measured by the author recognition test. Exposure did not predict IQ gains beyond reading skill. He included socioeconomic status. No effect beyond reading skill. He included parental education. No effect beyond reading skill. Reading ability was the unique predictor, the causal arrow points from reading to IQ. Spatial puzzles. These tests do not require reading, yet stronger readers improved more. The contamination explanation fails. Reading affects general intelligence, not just verbal skills. But the twin design controls for genetic influences on executive function. Identical twins share executive function genes. If executive function explained the reading IQ link, both twins would show similar IQ trajectories. They do not. The twin with better reading gains more IQ. This suggests reading has an effect beyond what shared traits would produce. They reanalyzed the TEDS data using state trait models instead of cross-lag models. State trait models assume stable traits influence both reading and IQ across time. Cross-lagged models assume reading at one age affects IQ at the next age. Tucker-Drob found that a state trait model fit the data equally well. Under this model, reading does not cause IQ changes. Instead, a stable environmental factor influences both reading and IQ at all ages. The stable factor might be something like home literacy environment or parental engagement. Once the stable factor is accounted for, reading no longer predicts IQ changes. Ritchie and Bates defended their cross-lagged approach. They argued that the state trait model makes unrealistic assumptions. It assumes the environment stays perfectly stable from age 7 to 16. It assumes no new environmental influences emerge. These assumptions are questionable. Children change schools. They make new friends. They develop new interests. The cross-lagged model allows for age-specific effects. Ritchie also noted that even if a stable environment drives both reading and IQ, improving reading could still boost IQ. The causal chain might be stable environment causes reading skill. Reading skill causes IQ. The debate continues. Most researchers accept that reading contributes to IQ gains, even if the exact magnitude is debated. Comprehension enables learning from text. Learning from text increases knowledge. Knowledge correlates with IQ. The chain is long, but each link is supported by evidence. Intervention works. Children with reading difficulties who receive intensive phonics in first or second grade catch up to peers. Their brain scans normalize. Their IQ scores rise. Not to the same extent as naturally skilled readers, but the gap narrows. Early intervention is more effective than late intervention. The brain is more plastic in childhood. Circuits wire more easily. Automaticity develops more fully. Waiting until 4th grade means missed plasticity. The circuits are less flexible. Compensation requires more effort. The child may learn to read but never love reading. The Matthew effect has already compounded disadvantage. Universal screening for reading difficulty in kindergarten. Free intensive tutoring for struggling readers. Extended school day reading programs. Summer reading camps. Access to books in low-income neighborhoods. Little free libraries on every block. These interventions cost money, but the return is measurable. 5 IQ points over 2 years translates to higher educational attainment. Higher attainment translates to higher income. Higher income translates to tax revenue. The economic case is strong. The moral case is stronger. Every child deserves to read fluently. Reading is the gateway to knowledge. Knowledge is power. They will link these outcomes to childhood reading skill. The hypothesis is that reading at age 7 predicts adult well-being through IQ gains. Children who read well become adults who earn more, live healthier, and report greater life satisfaction. Not because reading directly causes happiness, but because reading builds intelligence. Intelligence enables problem solving. Problem solving improves life outcomes. The chain is indirect, but real. A second wave of analysis examines DNA data. The TEDS study genotyped over 10,000 individuals. Genome-wide association studies identified thousands of genetic variants linked to intelligence. Each variant has a tiny effect. Together, they predict about 10% of IQ variance. This is called a polygenic score. Children with high polygenic scores tend to have higher IQ, but environment matters more than genes in childhood. The heritability of IQ increases with age. At age 7, about 40% of IQ variance is genetic. At age 16, about 60% is genetic. The increase comes from gene-environment correlation. Smart kids choose challenging environments. Challenging environments boost IQ. Genes indirectly cause environmental exposure. Reading is part of this process. Kids with high polygenic scores may enjoy reading more. They read more. Reading raises their IQ. The effect amplifies the genetic advantage. This is not determinism. Low polygenic score children who read a lot also gain IQ. Reading works for everyone, but the gains are larger for children predisposed to reading. Silent reading activates it in skilled readers. Poor readers do not show this activation. The skilled readers are covertly articulating the text. They subvocalize. The motor cortex prepares the speech gestures. This preparation strengthens phonological representations. Stronger representations support vocabulary learning. Vocabulary correlates with verbal IQ. The gray matter change in this region predicted 75% of the IQ change. The biological mechanism links reading behavior to brain structure to cognitive ability. The link is not metaphorical. It is physical. Neurons wire together, synapses strengthen, cortical thickness changes, white matter myelinates. The brain reshapes itself in response to reading practice. This is neuroplasticity in action. This network activates during rest, mind wandering, and autobiographical memory. It also activates during narrative comprehension. Fiction reading engages the default mode network more than nonfiction. The reader simulates the story world. Characters become mental models. Events become simulated experiences. The default mode network integrates these simulations with prior knowledge. Frequent fiction reading trains the network. The trained network supports complex mental simulation. Complex mental simulation correlates with social cognition. Social cognition correlates with fluid intelligence. The pathway from fiction to IQ runs through mental simulation. The effect is speculative. Brain imaging studies show default mode network activation during story reading. Longitudinal studies show that avid fiction readers have better theory of mind. Theory of mind correlates with IQ. The chain is plausible but not proven. The meta-analysis did not examine IQ outcomes. But if reading skill causes IQ gains, interventions should boost IQ. Few studies test this. Phonics interventions improve decoding and vocabulary. Vocabulary is a component of verbal IQ. Therefore, phonics should raise verbal IQ. Studies confirm this. Effect sizes are small, around 0.2 to 0.3, 5 to 7 IQ points over 2 years. Modest, but real. The gains persist at follow-up. Children maintain the advantage. The intervention changes their trajectory. Whole language does not. The evidence is overwhelming. Countries that adopted whole language in the 1990s saw declining reading scores. Countries that retained phonics maintained scores. The debate is settled. Phonics builds decoding. Decoding enables reading. Reading builds intelligence. One twin reads at 12th grade level by age 10. The other reads at 6th grade level. Both have the same parents, same books at home, same school. What explains the difference? Researchers dig into teacher reports, parent questionnaires. The twin who reads better had a first grade teacher who emphasized phonics. The other twin had a teacher who used whole language. That one difference compounded. The good reader read more. The weak reader avoided books. By age 16, the IQ gap reached 15 points. 15 points from 1 year with one teacher. Now, this is not common. Most teacher effects are small, but it illustrates the potential of early experience. One effective intervention at the right time can change a life trajectory. One twin befriended avid readers. The other did not. Peer influence matters. Reading is social. Kids who see friends reading want to read. Kids whose friends avoid books too. Parents cannot control friend choice completely, but they can expose children to book-loving peers. Libraries run reading clubs. Schools have book buddy programs. These environments normalize reading. Normalization drives behavior. Behavior builds skill. Skill raises IQ. Extended absences harm reading development. Reading development determines IQ trajectory. Chronic illness is a hidden factor in IQ variance. Twin studies reveal it because one twin serves as the control. Single-child studies cannot isolate this effect, but the robotics twin improved in spatial reasoning. Both showed IQ gains. The gains were in different domains. This suggests that multiple activities can boost intelligence. Reading is not the only path, but reading is the most accessible path. Books are cheap, libraries are free. Not every town has a robotics club. Every town has books. Methylation is an epigenetic modification. It silences genes without changing the sequence. Environmental experiences trigger methylation. One twin exposed to stress shows different methylation than the unexposed twin. The TED study did not examine methylation in reading discordant twins, but the logic applies. Reading practice might alter gene expression in brain regions supporting language. The altered expression changes circuit function. Circuit function determines cognitive ability. Epigenetics provides a mechanism for environment to shape biology. Reading is an environmental input. The input modifies the epigenome. The epigenome modifies the brain. The brain determines intelligence. Anisotropy measures this directionality. High anisotropy indicates organized white matter tracks. Low anisotropy indicates disorganized or unmyelinated tracks. Children with high anisotropy in the left arcuate fasciculus at age 7 become better readers by age 12. Better readers gain more IQ. The pathway from brain structure to reading to intelligence is observable. White matter integrity at age 7 predicts IQ at age 16 through reading skill at age 12. The mediation is testable. Statistical models confirm it. Brain structure does not directly predict IQ once reading is accounted for. Reading is the mediator. Structure enables skill. Skill drives intelligence. They randomly assigned half to intensive phonics tutoring. The other half received standard instruction. After 1 year, the tutored group showed increased anisotropy in the left arcuate fasciculus. The control group did not. The tutored group also showed reading gains. Reading gains correlated with anisotropy increases. IQ tests at follow-up showed 5-point gains in the tutored group, 2-point gains in the control group. The difference was significant. The experiment confirms that reading instruction changes brain structure. Brain structure changes support reading gains. Reading gains produce IQ gains. The causal chain is complete. The returns compound over decades. A child who reads fluently by age 8 has a cognitive advantage that persists through college, career, and old age. The advantage is not fixed, it grows. Good readers keep reading. More reading keeps building intelligence. By middle age, the childhood reading advantage translates to superior problem solving, richer vocabulary, better memory, faster learning. These cognitive assets shape every domain of life. Career success, health decisions, financial planning, relationship quality, parenting. The long shadow of early reading stretches across the lifespan. The hypothesis is that strong readers build cognitive reserve. Cognitive reserve is the brain's resilience to aging and disease. More education, more mental activity, more reading all contribute to reserve. Reserve delays dementia. A 5-point IQ advantage in childhood might mean 3 extra years of cognitive health in old age, 3 years of independence, 3 years of quality life. The value is immeasurable. A mass grave in England holds the answer to a different question, not from Vikings, from modern poverty. Archaeologists in 2015 excavated a 19th century workhouse cemetery. Records listed names and causes of death. Literacy rates were recorded for some individuals. Literate workers lived 7 years longer than illiterate workers, 7 years from reading. The effect persisted after controlling for income and occupation. Literate workers made better health decisions. They read medicine labels. They understood public health notices. They avoided patent medicine scams. Literacy was survival. Intelligence was survival. Reading built both. The bones in that cemetery tell a story about reading and life. The TEDS twins tell the same story with brain scans and IQ tests instead of graves. Reading matters. It mattered in 1850. It matters in 2025. Children who read live longer, think better, earn more, suffer less. The twin studies prove it. The brain scans show how. The policy is clear. Teach every child to read. Teach them early. Teach them well. The rest follows.